Hello everybody, it is Mrs. Pound and we are studying Chapter 7 on chemical bonds from BJU Chemistry's 5th edition. Today I want to focus on the first part of section 7.2 on covalent bonding and Lewis structures. So our objectives today are going to be to describe how atoms form covalent bonds, name the elements that exist as diatomic molecules, and draw the Lewis structures of covalent compounds when given their names or chemical formulas. So covalent bonding. Some of these things we've already talked about, so some of it is a review and some of it is not. First of all, in covalent bonding, one or more electrons are shared between atoms of similar electronegativity. So again, I'm using the puzzle pieces to show that sharing in the region between them. They are often shared unequally because one atom will have more of a pull on the electrons than the other because it will have a higher electronegativity. It's usually two nonmetals. And when we describe these bonds, there is the bonding pair. These are electrons shared in the covalent bond. And sometimes there are also lone or non-bonding pairs. These are valence electron pairs that do not participate in bonding, and I will be pointing those out. What holds the bond together are electrostatic forces, and this is the attraction between opposite electrical charge. In that region between the atoms, there is a buildup of negative charge that is attracted to the positive charge of the nuclei. So it's opposite charges attracting. There are some diatomic elements, and there are actually very few elements that form diatomic elements. They are called the hydrogen 7. This is an easy way to remember them. It's hydrogen plus the 6 elements starting at element 7 that form a 7 on the periodic table. So the hydrogen 7 are these 7 elements here. Hydrogen is a diatomic element, and then we start at nitrogen, which has an atomic number of 7, and we draw the number of 7 here. And so it's nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, which are our diatomic elements. And those elements are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And all of these exhibit covalent bonding. Now let's take a look at Lewis structures. These are two-dimensional structures that show the bonds between different atoms. There are some symbols we need to know. A dash like this means that it's a bonded pair of electrons, 2 electrons. So whenever you see a dash, it represents 2 electrons. And 2 dots like this are unshared pairs of electrons. In covalent bonding, we can have a single bond where we share 1 electron pair. To demonstrate a Lewis structure, let's first start with diatomic chlorine. So what we're going to do is I will first do the electron dot structure for chlorine. So that looks like this. And I'm going to make the lone electron there a different color to emphasize that. And there's 2 of them, so I'm going to put chlorine over here. And I'm going to do the structure a little differently so that you can see how these go together like puzzle pieces. And the unpaired electron there. So you can see that those can both match up. So when I put these together like puzzle pieces, it will look like this. Now I'm going to take that shared electron pair and I'm going to replace it with a line for a bond. So here the shared electron pair is in the middle, And then the non-bonding pairs, so this is the bonding pair. The non-bonding pairs I just leave as dots around the chlorine. I'm going to show you another example with hydrogen. So here's the electron dot diagram for hydrogen. I'm going to change this to a different color though, so we can see that a little better. I'm going to do another hydrogen over here. And again, I'm going to put the dot over here so it's easier to match up the puzzle pieces. And then we'll put those puzzle pieces together and it will look like this. And then replacing that bonding pair with a line. This is my Lewis structure for hydrogen. Now note there are no non-bonding valence electrons around this one because hydrogen only has one electron there. And then let's also do this for water. So water, H2O, 2 hydrogens. So here's one hydrogen. Here's another hydrogen. And then oxygen. And it's bonding electrons there. So we can see that we can attach one hydrogen here, another one there. So when we do that, we get and we can see that this gives oxygen a bent structure, which it in fact has in real life. And replacing those bonded pairs with the lines, we get this. And water is in fact bent because those non-bonding electrons, those lone pairs, are in fact pushing and repelling the hydrogen. So it in fact does have this bent shape even in nature. Double covalent bonding, where we share 2 electron pairs. Now let's take a look at a double covalent bond. So for this one, I'm going to use molecular oxygen, O2. So 2 oxygens. And I'm going to give each electron a different color here. Or actually, I'm sorry. I'll give one atom its own color and another atom another color. And again, I'm changing that configuration just a little bit so it's easier to see how these match up. Now we see that there are 2 lone pairs, so these ones can match up, these ones can match up. So we can redraw that like this. And then we see that we have 2 bonds here. And so we put 2 lines in for a double bond. And it looks like this. So that is oxygen, molecular oxygen. And triple covalent bonds, where we share 3 electron pairs. Finally, I'll show you a triple bond here. So for a triple bond, I'm going to use molecular nitrogen. So N, oops. So it has 3 unpaired electrons. Maybe this marker will work better. There we go. So 3 unpaired electrons on that one. And then we have a nitrogen over here. We'll give it 3. And we can see here that we can match up these electrons, these, and these. So we can form a triple bond like this. With all 3 of those in the middle. And then replacing those 3 pairs with the lines for a bond. So that's how we represent a triple bond using Lewis structures. Now that we've taken a look at a few Lewis structures for some very simple substances, let's take a look at something a little more complex. Let's take a look at formaldehyde, which has a formula of H2CO. The first thing we want to do is write the electron dot symbols. So now I'll show you how to do a Lewis structure for something a little more complex, like formaldehyde. And so the first step is to write the electron dot symbols. So step 1, I'm going to write those symbols. So oxygen, carbon. Now notice for the carbon hybridizes, the sp orbitals are hybridized. So what I have done is I have spread these out instead of putting the 2s electrons together. And then hydrogen like that. The second thing we do is determine the number of valence electrons in each. When we look at hydrogen, we have 2 atoms of hydrogen, each having 1 electron. And so we have 2 valence electrons. For carbon, 1 has 4 valence electrons, so we have 4 valence electrons. Oxygen, just 1 atom, 6 valence electrons, so for a total of 6 valence electrons there. So our total valence electrons is 2 valence electrons. This is important for making sure we have all of our electrons accounted for at the end. The third step is the atom with the largest number of unpaired electrons goes in the middle. Step 3 is to take the atom with the largest number of unpaired electrons and put it in the middle. So that is our carbon. Fourth, the remaining atoms go around the center atom, like puzzle pieces. Step 4 is to take that carbon atom and put the remaining atoms around that center atom. So we have a hydrogen that we'll put over here, a hydrogen up here with its 1 valence electron, and oxygen over here. Fifth, we create single bonds. Step number 5 is to create single bonds. So if we take a look at our picture there, I'm going to then take my carbon, my hydrogens, and my oxygen, and I'm going to line up those electrons so that they form bonding pairs. And so I have 3 single bonds there. But I have another lone pair there. 6, we create double bonds with the remaining unpaired electrons if there are any. If there's not, we're done. So going on to step number 6, I now create double bonds with the remaining unpaired electrons if we have any, and we do. We have one right there. So I'm going to take my carbon, going to move that electron up there. Here's my oxygen. I'm going to move the other electron over here. So now I've formed a double bond. And then I'm going to attach my hydrogens that I already had single bonded up here. And 7, we count the electrons. They should equal step number 2. If it's correct, we draw dashes for the bonds. Now, step number 7 is to count my electrons. And if I have the correct number of valence electrons, to put in my dashes for bonds. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have the correct numbers, so I will replace those bonded pairs with my lines. And this is what I have. This is what the Lewis structure for formaldehyde looks like. So our objectives today were to describe how atoms form covalent bonds, name the elements that exist as diatomic molecules, and draw Lewis structures of covalent compounds when given their names or chemical formulas. So don't forget to write your 5 questions in the margin.